Hey everybody, this is JoJo, the HVAC man. Good to see you, or I guess good to be seen from wherever you are in the world, whatever day it is, whatever time or night it is. I really appreciate you coming in, and hopefully today I will help you understand defrost control boards better and how to diagnose them and some of the common problems. Like this little fella right here, demand defrost, or this guy right here, which is the time temperature defrost control. So before we get started, let me give you a few words from my sponsors. Yep, that's all we got because I ain't got no sponsors. See you in a minute. Okay, here we go. First of all, we got time and temperature defrost, okay? But what that means is that defrost initiates on time and temperature, and that's going to be the time that is selected on the defrost board and the temperature of the coil that the temperature sensor is reading. Then it's going to terminate on time or temperature, okay? So time and temperature to come on and defrost, time or temperature to go off. Remember, in defrost, a few things happen. The outdoor fan shuts off, the reversing valve goes back to the cooling mode, and we get auxiliary heat coming on to temper the air while it's in defrost, okay? Now, whenever we have one of these time temperature boards like this, okay, we've got a few options. One, depending on the board, it may be dip switches. This one has got the older jumper style, but you're going to be able to select, that is, 30, 60, or 90, sometimes 120 minutes. And what that means is, let's say we got this set for 60 minutes on this particular board. What that means is every 60 minutes, the defrost board is going to see if the defrost thermostat is closed. Now, the defrost thermostat for a time temperature board clicks onto the outdoor coil and reads its temperature, and it looks like this, okay? It clips to the unit, and this is pink wires for a carrier unit, maybe black wires or brown, I don't know, depends on the model, but it's going to be this type. It opens and closes on temperature, and it then connects to the board. All this is an open or closed switch, so you're just going to ohm it out to see if it's closed or open, okay? So let's say that the timers went around and it's 60 minutes, and it goes and it looks to see if the defrost thermostat is closed, and it is. If it is, it will initiate defrost. What that means is the outdoor fan goes off, the heat strips come on, and we convert back to cooling to frost the coil during the wintertime. And how that all works is a whole nother class, but just talking about defrost boards right now. So you're going to have an understanding of defrost to begin with. But this is what happens when your unit doesn't work. So the frost, just remember defrost, heat pumps can frost up to about the surface of the coil guard. If it starts getting past the surface of the coil guard and building, then we got a defrost issue. Frost is normal in, wet climate, cold, wet climates. But, getting past those coil guards is when we start thinking, we probably got an issue, all right? So if you go to a unit and it's not defrosting, so it's all caked up with frost and ice, then the first thing you could do, right, is ohm out our switch. Just, take it loose from the board. And I'm assuming you got to know how to use a meter in this particular training I'm doing. So you take your meter and you ohm it out. Take it loose from the board, you ohm out this sensor. Now, if this ohm's closed, zero resistance, and you're in ice, then the sensor's good, okay? It's not the sensor. If you ohm the sensor and it's buried in ice and it's open, then that's bad, okay? Because it should be closed if it's buried in ice, okay? The other thing you want to know is that these boards work having 24 volts going to them at R and C. If we don't have R and C going to that board, it will not work as far as defrost goes. Now, if it's just got R and it's lost common to it somehow through a loose connection, then the R will continue to work through the board to run everything else. So the defrost board can run the compressor, can run the outdoor fan, or run the 24 volts over to the compressor. It can open and close the contactor for the outdoor fan without the common coming to the board. And then in the winter, boom, it won't work. So always verify you got R and C at the board. And that's going to be a little plug over here with your 24 volts. Then from here, it comes out of these connectors right here. And then here's your defrost thermostat connection right there. Now, the other thing you want to know is that this board also controls the outdoor fan right here on these contacts. So let me see if I can do this well for you. All right. Woohoo. All right. There we go. All right. Get my magnifying glass here for you. So here is the contacts that one leg of the outdoor fan motor goes through. That's what that OF1, OF2 stands for. So the outdoor fan goes through the defrost board, and when it goes in defrost, it opens up those contacts. However, sometimes the defrost board relay can go bad, and in the summertime, your fan won't be working, and you'll check your capacitor, but then also check to see if these contacts are open. If this relay is open in the summertime, then you got a bad defrost control board, or it's stuck in defrost. Because here's the other thing that can happen is your sensor, our handy dandy, clicks on sensor here, open and close, could get stuck closed. Well, in the summertime, this board is still active. So you got the timer set for 60 minutes. Every 60 minutes, it goes to look to see if that sensor is closed. Summer or winter, it does not matter. So if that sensor is closed in the summer, then guess what? The outdoor fan shuts off. Unit's already in cooling, so the reversing valve just stays where it's at, and the indoor heat strips come on. The customer says, sometimes my unit shuts off, and it smells like a burning smell up in my ductwork. And you're running to the fan motor, or you're running to the outdoor unit or a contactor or whatever. But when you get there, everything's working fine. You go and maybe you'll test the defrost board, right? Maybe you'll go over here and you'll do the little speed up. And on this little board right here, speed up is also speeding up the timer in the defrost board. And it goes into defrost and everything's fine. And you're thinking, okay. But should it go into defrost? Not if it's summertime. It should never go into defrost. So if you do a speed up on this joker, and all of a sudden it goes into defrost, we got a problem, okay? Ohm out the defrost sensor. There's the problem. The customer says their unit cuts off because the outdoor fan shuts off. And they look out there and see it not running. Also, that's going to cause the compressor to trip out. So now they're not going to have any cooling. And it brings on the heat strip, so now they're smelling the burn smell in their ductwork. So don't forget, even in the summer, the defrost board could be a problem. And it's going to be the sensor in most cases. Now, really, that's the quickest way to troubleshoot this board, okay? Now, every manufacturer's got a little nuance to how they want your boards tested. This one here, you're going to jumper the speed up pins, but some of them will tell you, as soon as it goes into defrost, take the jumper off the speed up pins, and then it will stay in defrost for like 10 minutes, okay? Others will tell you to jump out the defrost sensor and then do the test. Others will tell you that their board will internally bypass the defrost sensor, and then all you got to do is do a test. So read their instructions, but in the end, time defrost must have the thermostat satisfied on the coil and the time before it goes into defrost. After that, it goes into defrost, and it comes out either by temperature or time. So either this warms up enough to let it come back out of defrost. What that temperature is varies on manufacturer, but you know that the coil's got to be below freezing to frost up. It's got to be above that to warm up. So I don't know, you can do it around 40, 45 degrees, but in any case, this guy, okay, is what you want to check to see. But it's going to warm up, and if it opens a circuit, the defrost board will come out of defrost. No problem. Or if it's so cold outside that it didn't thaw the ice out and it didn't didn't thaw the ice out, and maybe this was stuck closed, right? Then these boards have an internal maximum time of defrost, which can be anywhere from 10 minutes to 14 minutes, depending on the manufacturer. Again, their literature will tell you exactly, but nonetheless, there's a maximum time these will stay in defrost regardless of what the coil looks like. So you could be one of those icy rain conditions where we're just getting so much moisture and so much cold that the defrost board can't keep up. Some guys will come around and some technicians will set all these boards to 30, just to be, get it to go into defrost earlier. Some out of the manufacturers, I think, usually they're set on 90, or maybe 120 if you got a newer board. But a lot of them just turn them back down to 30. Now, it won't go in the defrost unless the temperature sensor is closed, so that really doesn't hurt anything to do that, okay? So that is time temperature. Told you this was quick and dirty, right? Next, demand defrost. Like I say, other manufacturers have, intelligent defrost or adaptive defrost or smart defrost or, I don't know, luxury defrost. All right. But it's demand. It's adaptive. It's adapting to the environment. So what they do is demand defrost boards are pretty easy to recognize. Give me a little focus here. Okay. They're going to have, instead of a time selection, right, 30, 60, 90, they're going to have an ambient sensor and a coil sensor. Here's our ambient, here's our coil. And these two sensors are going to be reading outdoor air and the coil temperature. So let me show you one of these sensors here. This is an ambient sensor, okay? They're usually black, and they either look like a little bullet like this, or they may look like a little wire, a loop of a wire, and they're going to hang down in the control panel, right below the control panel usually, just so they can read outdoor air, not to be affected by sunlight, okay? So that's going to hook on the board to the ambient side. So outdoor air temperature is ambient, so we're trying to read the air around the outdoor coil. And then you're going to have another one, which is going to be sensing the coil temperature. And they look, believe it or not, like that little black section of this wire. This will be pushed into usually a little well that is brazed onto the outdoor unit copper so that it's reading the coil sensor, is reading the temperature of the coil itself, okay? All right, and that is going to be plugged in over here to the coil. So, while this is running, these boards are a bit smarter. One, they know they're in the heating mode, so they don't go bad. They won't go in defrost into cooling mode. And then they are looking at outdoor temperature and coil temperature at the same time. To initiate defrost, once it gets into the heating cycle, it's going to look at each sensor, by the way, has a little different nuance, and there's spec sheets for this, but that doesn't matter. In general, let me just say this, that at about 52 degrees outside, it's going to look at the coil sensor. If the coil sensor is at a minimum temperature, I think like 32 or 31, somewhere around there, then it'll go into defrost. It'll initiate defrost for the first time, okay? And it's going to determine, and some of them will actually initiate defrost even if the coil isn't cold yet. It's just got to be 52 outside. It will determine at what coil temperature at 52 degrees, how fast it warmed back up to a higher number, okay? And it will record that time. Based off of how quick it raised the temperature of the coil back to its desired temperature, it will calculate when it's going to go back and defrost again. So now it's going to look at 52 degrees in the coil sensor. It's not going to be cold enough. It's going to go back around and check it again. When it finally gets cold enough to go into defrost, it'll measure how fast it warmed the coil up again at that outdoor temperature. It's going to base on a new calculation, wait, and try it at a colder outdoor temperature before it looks at cold temperature. And let's say it does that again. Let's say it picks 45 degrees. And then at 45 degrees, it looks at the cold temperature sensor. And if it's now cold enough to go into defrost, it'll measure how long it took to get up to the temperature it wants the cold to be again. And then it continues to look at outdoor temperature versus cold temperature to determine when is the least amount of time it needs to go into defrost. Because if you're in a dry winter climate and it could be 28 degrees outside, but there's no moisture in the air, you won't have any frost in that coil. And it will not go into defrost after it starts determining that it just warmed that coil up just like that. But if you're in, let's say, 30 degrees outside, we got one of these ice storms coming in, or it's 25 degrees and it's buried in ice, and when it hit the cold temperature sensor and it started to warm it up, and it took an extra long amount of time to warm that coal back up, and it's going to recheck at a different temperature on that outdoor sensor. And it'll continually adjust the time it looks, the temperatures it looks for on a regular basis so that it only goes into defrost when it absolutely has to. And that's why it's called on demand, because it only goes on defrost on demand. Now, how do you check it? There's really two ways to check this. It's very simple. Don't forget, it does have to have 24 volts on it, just like the rest of them. And then you've got these pins right here. Now, on the old ones, and these are still out there quite a bit, you had it. Show it to you. There we go. Okay. It had this little setup right here. And it had test common, TST, and FRC DF. Okay. So what that says, forced defrost, and that is test. So test common means you always go from either this post to this post or this post to this post. This is the common post or the defrost test. That's what test common means. Okay. So if you cross between test common and test, and what it does is it speeds up that initiated timer. It speeds up whatever time it is calculated to go look at the cold temperature sensor at a certain outdoor temperature. And you are going to make it go into defrost as long as all the sensors are working. So in effect, it bypasses the logic of the board. And as long as the sensors are all reading correctly, it'll go into defrost. So if you go to a unit and it's all iced up and you go over here and you jumper test common to test, and it switches into defrost and begins to melt all the ice off, okay, then what that's telling you is that the board has gone bad. Even though the sensors are good, the board's not doing its job. Now remember, we got to be sure that we do have 24 volts to the board and we have a full charge in the system, because a low charge in that system will also keep it from going to defrost. Don't forget that. Now, the other one, test common to force defrost, what it does is it's going to bypass the sensors. So if you come up to a unit, it's all iced up, and you do test common to force defrost, and it goes into defrost, then the board is good. It's one of the sensors that are bad. Easy enough? That's really it. One will separate the sensors out of the equation, and the other one will separate the board out of the equation. Now we've got another style, and what they did is they just put it right here on the board. But you do the same thing. You either short test common to test or test common to force defrost. And that's it. Okay? Now, how do you check these guys? How do you check the sensors? Well, they'll have a chart. Hang on, everybody. There it is. You can see that now, can't you? Okay, so this chart here will tell you the resistance based off of temperature. And if it's, say, 32 degrees outside, it'll be about 32,000 ohms of resistance. Now, this chart is out of the defrost manual. that is for the equipment itself. The chart is also out on the internet. You can look up a thermistor resistance chart. And it's going to be the resistance based off of temperature. So if the coil's buried in ice and the temperature sensor, the ambient is buried in ice, then it should read about 32,000 ohms. Okay. If the ambient air is, say, 30 degrees outside or 25 degrees outside, then the ambient sensor should read the resistance that's equal to 25 degrees. And that is it. So I hope that helps. It's quick, down and dirty, but maybe it'll get you out of some trouble there with defrost boards. Got any questions, any comments, please let me know and I'll be glad to respond back. And y'all have a great day or night, wherever you are.